It's Dr. J coming back at you with some more applications. This will be part 2. Today we're going to talk about doubling time. These videos are taking quite a long time to upload, so I'm going to go ahead and just do a real quick one to get it up there. And then I'll come back and finish it at a later time, because we want to go from doubling time, and we'll first talk about money, but our ultimate goal is to get into some other things that may not involve money, and there's some related terminology. But I left you off yesterday with this continuous growth. Also known as compounded continuously. And there's a neat rule of thumb. We call this the rule of thumb. The rule of thumb is that a 10% interest for a time of 7 years, any investment will double in 7 years. So it's the 7-year doubling rule. And it gives us a really cool trick. Let me first demonstrate how this works, in case you didn't catch it last time. We're using the continuous growth formula, or the compounded continuously formula, and we want to double our money. So we want the amount, the future amount, to be double the principal. All right, so A is the future and P is the present. So this happened in yesterday's lecture when I replace A with 2P, substituting 2P for A. Dividing both sides by P, and the principal becomes irrelevant, and you have this as your doubling time formula. So whenever you're solving a problem involving doubling, you're always going to have an exponential function equaling 2, because the original amount ends up canceling out, and you will always have a factor of 2 when something is doubling. Okay, and then why 7? You know, why 7? Why does it come out to be 7? Well, it's just a fact of the number 2. When you take the ln of 2, you're going to get 0.69, I think I might have done this yesterday. ln of 2 is 0.693147, etc., etc. The logarithm and the exponential are going to cancel out. That's our inverse property. And we're just going to get RT. For practical purposes, when we're talking about time, we're doing word problems involving time, this might as well be 0.7. So we have RT is equal to 0.7, or approximately 0.7 if I really want to get into it. And so, clearly, if I say the rate is 10%, I have 0.1, T is approximately 0.7. We could divide both sides by 0.1, and we get T is approximately 7/10 divided by 1/10, that is 7. If you don't believe me, I hope you do, but if you don't, 0.7 divided by 0.1 equals, and there it is, your 7-year itch. So, At a 10% interest rate, compounded continuously, you can double your money in approximately 7 years. For practical purposes, we just say 7 years. So that's where that rule comes from, but let's see how handy this rule actually is. You're not always going to get 10%. The interest rate could change. So we could take this formula here, RT is approximately 7/10. And watch what happens. Given any interest rate, R, we can easily solve for T using this general rule of thumb. So the rule doesn't just give us one solution, but it'll give us the solution to any type of doubling problem, provided that it's continuous growth, continuous compounding. So for example, how long will it take to double at 2% interest? That's a lot more realistic, right? Because you're not really going to get 10% interest, not in this world, not in this current economic climate. Well, 2% interest, 2%, that's R is 0.02. Put that into here. RT, for practical purposes, why don't we just say equal to 0.7. We're going to plug in 0.2. We get a formula. T is 0.7 divided by R. That's 0.7 divided by 0.02. Or if you like, you can write this as 70 divided by 2. Just multiply the top and the bottom by 100. The numerator and denominator multiplied by 100, you get 70 divided by 2. That's going to take you 35 years. Much easier than going back and solving the entire problem. Let's try it again. How long will it take to double at 5% interest? Right. Use the same formula. T is 0.7 divided by R, which is 0.7 divided by 0.05. That would be 5%, written as a decimal. Multiply the top and bottom by 100. You get 70 divided by 5. 70 divided by 5 is 14 years. So that is the handy-dandy rule of thumb. I'm going to go ahead and stop there and upload this. I'll finish the lecture as a separate upload. I will title this 4.6 Rule of Thumb. Check in with me later for the rest of the lecture.